Hi guys, you're welcome to my channel. So today we are going to be looking at some questions from Jamb on projectile motion. If you are yet to watch the lecture on projectile motion, you can check the description box and you're going to find the link to the video there. Watch and understand everything about projectile motion. Also, special thanks to those that really make this video possible. That is the channel members, people like Chukwu Adaize and Olu Femi. Thank you guys. I so much appreciate you. It is because of you that we are having this. All right. So without wasting much of our time, so let's get started. So the very first question here states that a palm fruit is dropped to the ground from the top of a tree 45-meter tall. How long does it take to reach the ground? Take G as 10 meter per second square. So this question is from Jamb 1978, question number 4. So how do we solve this? Let's see solution. Now, a palm fruit is dropped to the ground from the top of a tree 45-meter tall. So we have the height of the tree to be 45 meter. How long does it take to reach the ground? So we are looking for the time, and then we are given G equal 10 meter per second square. So the first thing we want to do is to quickly recall the equation of motion that has to do with this particular question. So if you look at this question very well, you guys to see that it is motion under gravity. So since the body falls from the top of the tree to the ground, so initial velocity becomes 0 meter per second, because when you are dealing with motion under gravity and a body fall to the top of a platform, initial velocity becomes 0 at that point, and at maximum height final velocity becomes 0. So if that should be the case, the whole of the equation of motion that we have includes V equal U plus gt. We also have that h equal ut plus half gt square. Then we have that v square equal u square plus 2gh. So these are the equations that we have for motion under gravity. Now that u is equal to 0, so this equation here will reduce to become gt, and this one will reduce to become h equal 1 over 2 gt square, and this one will reduce to become v square equal 2gh. Now if you look at the parameters given in the question, we have the height to be 45 meter, we are looking for time, we have gravity. So we have to look for, out of these three equations here, the one that has height, time and gravity. So if you look at this now, this one has velocity, gravity and time, so we cannot use it. So this one has velocity, gravity and height. There's no time that we are looking for, so we cannot use it. But if you look at this has the three things that will enable us to find the unknown. So we just pick this second equation and say 45 meter is equal to 1 over 2 times. So the G is 10, then multiply by t squared. So 2 here 1, 2 here is what? 5. So we have that t squared equal 45 divided by 5, and that will give us 9. So t equal square root of 9. So your result is going to be plus or minus 3 seconds. So as of course time cannot be in negative value, so it has to be positive. So our correct answer there is going to be E, which means that the time is 3 seconds. So I believe that we understand this now. Okay, so let's move to the next question. So the next question is 1991, question number 5, if I'm not mistaken. So the question states that that should be 1981. Okay. The question states that a ball, a small metal ball, is thrown vertically upwards from the top of a tower with an initial velocity of 20 meters per second. If the ball took a total of 6 seconds to reach the ground, to reach the ground level. Determine the height of the tower. Take G equal 10 meters per second square. So if you look at this question, also still under the one-dimensional projectile, and we have to look for what the solution will be. So this particular question is question number 3, 1991. So how do we solve this? So let's take the question again so that we can be able to write out the parameters given in the question. All right, so a small metal ball is thrown vertically upward from the top of a tower with an initial velocity of 20 meters per second. So our initial velocity is 20 meters per second. If the ball took a total of 6 seconds, so the time that takes the ball is 6 seconds, and to reach the ground level, determine the height of the tower. So we are looking for the height of the tower if G equal 10 meters per second square. So in this kind of a question, it should be good for us to play safe by making sketch of the diagram. So let's say this is the top of the platform, and here is A, here is B, and this is the total height covered by the ball, which is top C. So for an object thrown vertically upward, the motion is retarding. That is retarding to rest under gravity. Hence, we have that our final velocity is equal to 0. So if final velocity becomes 0, A is already G because we are dealing with a vertical motion. Then the three equations of motion will reduce to become U equal GT, H equal 1 over 2 GT square, and U square equal 2GH. So this will be the whole of the equation that we have right now. So from the point B to C, that is from here to this place, we have that U is equal to GT. That is the initial velocity is equal to the acceleration due to gravity times time. So we want to really know the time that takes the body to move from the top of this platform to this particular point here, because the 6 seconds given to this place here is the total time used in the motion. So let's know the time that takes the body to move from here to this place. So if that should be the case, we have that the time T is equal to U over G. So that will give us 20 over 10, and that will just be 2 seconds. So it takes 2 seconds for the body to move from point B, which is at the top of the platform, to the very top of the tower. Okay, so if that should be the case, what's the distance between B and C? That's the second thing that we need to find out. So the distance between B and C is going to be S equal 1 over 2 GT square. So this will give us 1 over 2 multiplied by 10 multiplied by, so the time that takes the body to move from B to C, that's 2, so that will be 2 squared. We therefore have that 2 here 1, 2 here 5, so that will be 5 times 4, that will be 20 meters. So the distance to move from B to C is actually 20 meters. Now, as the total distance from B to C, and also from C to A is 6 seconds, like we are given in the question. The time that takes the body to move from this top of the platform to the top of the tower, which is 2 seconds, and then from the top of the tower down to the base of the platform. So the whole of the time taken is what? Is 6 seconds. So we can easily identify the time that takes the body to move from B to A. So if that should be the case now, we say the time for the body to move from C to A is given as 6 minus 2, and that will be 4 seconds. So that's the time that takes the body to move from C back to A. Are you getting that now? Since the time that takes the body to move from B to C is 2 seconds, so the time that takes the body to move from C to A is going to be that 2 seconds minus the total time taken. So if we have 4 seconds to cover the distance between C and A, then we can use that to calculate for the distance that is required. So the distance required, which is the distance CA, is equal to 1 over 2 GT squared. So we have 1 over 2 times 10 multiplied by 4 squared. So that will give us that will be 5 times 16. So 5 times 16 is going to give us 80 meter, if I'm not mistaken. So if that should be the case, so the height of the tower that we are looking for is therefore going to be the total distance, that is both the height of the tower and the height of the platform, that is 80 meter minus what? 20 meter. So that will give us 60 meter. So that is the height required from the question. So that's the height of the tower, and that will be option A. So I hope we understand the analysis of this particular question. So let's move to the next one. So for this very one, we have that this is Jamb 1988 question number 10. 1988 question number 10. The question tells a ball is thrown vertically upwards from the ground with an initial velocity of 50 meters per second. What is the time spent by the ball in the air? So when I say the time spent by the ball in the air, what they are simply referring to is the total time taken. I get it now, which we can also refer to as time of flight. So how do we go about that solution? So read the question again to interpret the parameters given. A ball is thrown vertically upward from the ground with an initial velocity of 50 meters per second. So the initial velocity is 50 meters per second. What is the total time taken or total time spent by the ball in the air? So we are looking for capital T, and then we have our G to be 10 meters per second square. So what are we going to do right now? So what we are to do is that we should recall that T equal 2U divided by G. So this particular equation has been proven in the class, so you can just watch the video if you have not taken the class before, so that you are going to understand how we come about this particular equation. So we have 2 times 10 divided by 10. Sorry, 2 times 50 rather, so because the initial velocity there is 50. So we have 2 times 50 divided by 10. So this and this will cancel, and we have that the total time taken is 10 seconds. So that will be option C. So we'll move to the next question, and that's Jamb question 1981 question 1. 1981 question 1. So the question tells a particle is projected vertically upward with a velocity of 20 meters per second. What maximum height does it attain? Take G equal 10 meters per second. So we have that a particle projected vertically upwards with a velocity of 20 meters per second. So we have that our U is 20 meters per second, and our G is 10 meters per second square, and we are looking for the H max. So we recall that H max, that is maximum height, is equal to 2U squared all over G. So sorry, we have that our maximum height is U squared over 2G. So this is the formula that we have for the maximum height. So if this is what we have, then we can say our initial velocity is 20. So we'll say 20 squared divided by 2 times 10. And this will give us 400 divided by 20. So this and this should cancel, and then we have that the maximum height reached is going to be 20 meters. So 40 divided by 2 give us 20. So the correct answer to that question is going to be option C. Yeah, so 20 square, what was it called? 20 square is going to give us 400, and then we have 2 times 10, that's 20. So this and this would cancel, so we have 40 divided by 2, and that will give us 20 meters. All right, so if that should be the case, now we can move to the next question now, and that will be question 2009, question number 8. 2009, question number 8. So how do we go about this? The question says a bullet fired vertically upward from a gun, head 2.0 meter above the ground, reaches its maximum height in 4 seconds. Calculate its initial velocity if g equal 10 meter per second square. So how do we go about this? It's very pretty much simple. So all we just need to do is to interpret the question the way it has been given. So you can just write down, so a bullet fired vertically upward from a gun held 2 meter above the ground. So if you have this 2.0 meter above the ground level, I don't think this have anything to do with the question, but let's write down with the interpretation. Above the ground level reaches its maximum height in 4 seconds. So the time that takes the body to reach its maximum height is 4 seconds. Calculate its initial velocity. So we are looking for the initial velocity, and we have that the acceleration is 10 meters per second square. So when you look at this scenario now, we are strictly dealing with what the kind of velocity that the body is launched with, for the body to come down, for the body to return back to the plane of projection, or to get to the maximum height. For the body to get to its maximum height in 4 seconds. So if that is what we are looking for, then there's no point considering what the height in which the gun is being held. Are you getting it now? Because there is no any further information that can make the height useful. So you need to know how to point out all of these kind of parameters that are not useful in your question. So what do we do next? So we call that V equal U plus AT. So since it is motion under gravity, A is equal to G, and at maximum height, V is equal to 0. Therefore, we have that U equal what? GT. Because the body is going up, so A will be negative G, since it's retarding. So if that should be the case now, so we have the initial velocity to equal to G, which is 10 multiplied by what? Multiplied by 4. So we have that our G is equal to 40 meters per second. And that's option C. All right, so we'll move to the next question, and so the next question states that a stone. The question states that a stone Q is thrown with velocity u at an angle of 75 degrees to the horizontal. So we have that theta is equal to 75 degrees. Another stone R, so let me take that now. Stone Q, so the theta for Q is equal to 75 degrees to the horizontal. Another stone R is thrown with the same velocity u, but at an angle of 15 degrees to the horizontal. So the theta R is 15 degrees to the horizontal. The range covered by the stone will be A greater for Q, B greater for R, so and so like that. So one thing you should just notice that for us to be able to solve this question correctly, all we just need to do is to recall the formula for range. So range of a projectile is given as what? Sine u square. We have this to be u square sine 2 theta all over g. So this is the range of a projectile, and then we are trying to compare the value for the two. So let's just say both u and g is 1. Are you getting this now? So we have that r equal sine 2 theta. So we have that sine 2 theta, if it is 75 degrees, 75 multiplied by 2, so that should give us 150, right? So that's sine 150. and we have what's it called, that of r will be 15. That will be sine 30, because 2 times 15 will give us 30. So by the time you press your calculator for sine of 150, so sine of 150 is the same as sine of 30 degree. So that is going to give us 0.5, if I'm not mistaken. So you can press a calculator to check that, because right here I'm not with any calculator. So for that reason, if you look at that now, by the time you press your calculator for sine of what's it called, 75 degree, you should be having a result that is similar or the same with what's it called, with that of 30 degree, because sine 150 degree sine 150 degree is equal to sine of 180 minus theta. So sine of 180 minus theta is the same thing as sine of theta. So if I have that the angle is 150, that means that theta is 30 degrees. So I'm having 180 minus 30. So 180 minus 30 is going to give us 150. Therefore, sine of 150 is the same thing as sine of 30. So what will be the right answer to that question? Since this and this are equal, sine 150 is equal to sine 30. So A greater for Q, B greater for R, C the same for Q and R. So it is the same for Q and R. So do we get that right now? So we can move to the next question. So that's how to solve such question that has to do with comparison. So the next question here states that an object is projected with a velocity of 80 meters per second at an angle of 30 degrees to the horizontal. The maximum height reached is. So the question is, an object is projected with a velocity of 80 meters per second. So the velocity is 80 meters per second at an angle of 30 degrees to the horizontal. So theta is 30 degrees. So we are looking for the maximum height. So what's the maximum height? H max is equal to u square divided by u square sine square theta all over 2g. So we have u square sine square theta over 2g. So that is the formula to calculate for the maximum height of a two-dimensional projectile. So when you watch the video for projectile, you get to see how to derive all this equation. It's very, very important that you watch the video so that you can know how to go about all of this formula. It's not just a formula that somebody just cook and just drop. So you are going to understand it better when you watch the video. So u square, what's our u? 80. So we have 80 square multiplied by sine square theta. What's our sine square theta? So we say into bracket sine 30 all square divided by 2 multiplied by 10. Am I making sense now? But if I have this, what's the next thing to look at? 80 square to give us 1600, if I'm not mistaken. So that is 80 times 80, then multiply by sine 30. So please don't make a mistake by squaring 30. So sine square 30 simply means sine 30, the result you have all square. Do you understand that now? So, and when you say sine of 30 all square, so what are you going to have? You're going to be having 1 over 2 square, and that will be 1 over 4, right? So if you multiply 1006 by 1 over 4 divided by 20, so your result is going to become okay, kindly check, is there no mistake here? Let's check. 80 multiplied by 80, so this will give us 0, this will give us what's it called, 0, okay, 0, this is 64. Oh, so it's supposed to be 6400, yeah, not 1600. So we're supposed to have 6400. So 6400 divided by 4, so this should give us 1600 all over what? 20. So that this and this can cancel. So we have 160 divided by 2, that will give us 80 meter. And that will be the correct answer to the question. So I believe you understand this now. Please be careful of this. Don't square 30, please. You have to square the result of sine 30, not to square 30 itself. So the next question here states, okay, so this is what we have for the next question. And this is 1988 question 9. 1988 question 9. So let's see what it looks like. Let's see if we can put solution to that also, just like we did for every other one. The question states that a catapult is used to project a stone. A catapult is used to project a stone. Which of the following energy conversion takes place as the stone is released? All right, so let's see. A catapult is used to project a stone. Which of the following energy conversions takes place in the stone? Okay. A, the kinetic energy of the stone is converted into gravitational potential energy. B, the gravitational potential energy of the catapult is converted into the kinetic energy of the stone. And option D, the gravitational potential energy is converted into elastic energy of the stone. And lastly, the elastic potential energy of the catapult is converted into gravitational potential energy of the stone. So how do we answer this question correctly so that we are going to be on a safer side? And when I say safer side, that you are going to be convinced that yes, the answer that you choose is really correct. That is, you are damn sure of your answer. So the first thing we need to do right here is to analyze each of the options. So each of the options, we need to explain why they are wrong and then why they are right. So with that, you yourself can easily pick out the one that is correct and the one that is wrong. So if you look at this now, the very first one, we said the kinetic energy of the stone is converted into gravitational potential. So when you look at what we have here, kinetic energy, so what the stone has before is potential energy. I get to understand, because kinetic energy is the energy that a body possesses when it is in motion. So this cannot be the answer because the body did not possess kinetic energy before. So when you are in motion, when you are at rest before and you become what? You start moving. You will convert your potential energy into what? Kinetic energy, not kinetic energy into potential energy. So there's no even point dwelling into what gravitational potential energy simply means. So that will not be the right answer. So B, the gravitational potential energy of catapult is converted into kinetic energy of the stone. It can be the gravitational potential energy of the catapult. Why? Because when I say gravitational potential energy, we are talking about the work done that you are going to do in bringing an object from infinity to a point of the gravitational field. So that's what we refer to as gravitational potential. And of course, the stone you want to throw is already on the gravitational field. It's not because it's not that you are bringing it from the space. So for that reason, this cannot be true. So the next one is the elastic potential energy of the catapult is converted into kinetic energy of the stone. Can this be true? I think so, because by the time you drag the catapult backwards, so you are having the so-called potential energy of what, of that particular catapult, that is elastic potential energy of the catapult. That is what you use to drag it back and hold it before you can release it. By the time you are releasing it, it is that elastic potential energy of that particular catapult that you are converting into kinetic energy of the stone. So for that reason, C is going to be the right answer to the question. Or I believe that is taken. So we can move to the next question. So this question here, 2006 question 19. The question states that a shooter wants to fire a bullet in such a way that its horizontal range equal to 3 times the maximum height. At what angle should he fire the bullets to achieve this? Okay, so we have option A, 53 degree, option B, 68 degree, option C, 50 degree, option D 45 degree. Now, because they are talking about range here, does not mean that the right answer to this question is going to be 45 degree. But it's so surprising that a lot of past questions in Nigeria, like those past questions company, they solve this particular question wrongly. Why? Because they felt they are talking about maximum range. And of course, you know, the only angle whereby the range of a projectile is maximum is when the angle is 45 degrees. So absolutely, every one of the past questions went for 45 degree without even showing workings. But can that be the answer? I'm not sure. But let's see and interpret the question and see how we can solve it. The shooter wants to fire a bullet in such a way that its horizontal range equal to 3 times the maximum height. At what angle should he fire the bullet to achieve this? So let's see how we can get that. So what is the objective of the person that wants to fire the bullet? So he wants the horizontal range to equal 3 times the maximum height. So that means range is equal to 3 times the maximum height. So you recall, what's the formula for range? Range is given as u squared sine 2 theta all over g, and the maximum height is given as so you remember 3 multiplied by the maximum height formula is given as u squared sine squared theta all over 2g. So g and g can cancel there. So if g and g cancel, we are left with u squared. So instead of this sine 2 theta here, because I'm seeing sine squared theta here, but sine squared theta cannot cancel sine 2 theta. So I can rewrite this sine 2 theta because from compound angle formulae, we have that sine 2 theta is equal to 2 sine theta cos theta. So I can rewrite sine 2 theta like this. So I will just put multiply by 2 sine theta cos theta out there. So that's equal 3u squared sine squared theta all over 2. So u squared can cancel what? U squared when you divide both sides by u squared, right? So if that should be the case now, sine theta can also cancel one of these sine theta when you divide both sides by sine theta. So cross multiply, you have what? 4 cos theta equal 3 sine theta. So what do you do next here? You want all the O theta to come one side and all the O numbers to also come one side. So how do we do that? I'm going to say divide both sides by 3 cos theta. So divide both sides by 3 cos theta. And how do I do that? I pick coefficient of the constant here, and I pick the coefficient of the trig ratio here. So that's what I use. So that this and this can just cancel, and 3 will just cancel here. So I have that sine theta over cos theta is equal to 4 over 3. And sine theta over cos theta is going to give us tan theta, and this is equal to 1.33. So theta is equal to the arctan of 1.33. So theta is equal to 53.1 degrees. So to the nearest 2 number, the correct answer there is A. So that is how we solve this particular question. It's not to think that they are talking about maximum height and you went ahead and picked 45 maximum range rather, and you went ahead and picked what 45 degree. That won't be the right answer. So we'll move to the next question, and the next question tells an object is projected from a height of 80 meters. So the height is 80 meters above the ground with a velocity of 40 meters per second. So the velocity is 40 meters per second at an angle of 30 degrees. So theta is equal to 30 degrees to the horizontal. So the time of flight is, so we have that time of flight is equals to 2u sine theta over g. So this is going to be 2 multiplied by our u is what? 40. So we have 2 times 40 sine 30 degrees divided by 10. So this and this can cancel. Then I have that t equal to 2 times 4, that's 8. So we have 8 sine 30. Sine 30 is 0.5, that is 1 over 2. 1 over 2 times 8, that will give us 4. So the time of flight is going to be 4 seconds. And that's option G. So this question is 2005 question number 4 or question 3. So any of the two. So the last but not the least question that we're going to be considering here, out of the whole of the questions that we found in the past question under this particular topic, I think it should be a bonus. 1995 question number 6. The question states that at what angle to the horizontal must the nozzle of a machine gun be kept when firing to obtain a maximum range for the bullet? So since we are talking about maximum range here, and you are going to agree with me, the range of a projectile is said to be maximum when theta is 45 degrees. So the correct answer to that question is going to be option D, which is 45 degrees. So at this point in time, we're going to call it a day on questions that has to do with projectile motion. So these are the questions that we found on projectile motion. So you can do as much as possible to also go into Waec past questions and look for more questions under projectile, just for you to get familiar with more questions on it, and before it gets to know, boom, you're ready to tackle the exam. So don't forget to subscribe to this channel if you are yet to subscribe. Share this video within your friend. We are here to let you pass this jam with ease. Thank you. See you in the next one.